are here on a new problem, no? Nahinay na gyud na nagyud nagkadugang sa ato ang problem solving. So here we have a block displaced at 10 millimeters and then released. We're asked to find the cycles of motion. So this is the total cycles, no, of the motion before the block returns to rest. So natay block diri, if imo nang i-move, no, i-displace na nimo mo, sayo mudagan na siya back and forth until it will stop. So we have here a coefficient of stiffness K, 10,000 Newton per meter. We have our mass is equal to 2 kilograms. But now here we have mu is equal to 0.12. What is mu is equal to 0.12? So if you remember with your statics of rigid bodies or dynamics of rigid bodies, this is the coefficient of friction. So did you know, if you, as you can see, there is no dash pot. This denotes viscous damping. But there is a static, what we call this static damping. And then this is due to the friction here. Or this is also called the Coulomb's damping. So kung mabalik na sa ito equation of motion, di ba, we have m double dot x plus c dot plus kx is equal to 0. But this one, we have the frictional force plus kx is equal to 0. So what is the frictional force? So we have a weight here, W, and then there will be a normal force acting on that one, which is equal to the mass times the gravitational acceleration. Now, if this block is being displaced along that way, so this is our positive x, the friction will oppose that motion. So we have our frictional force here, which is equal to mu n, or simply mu mg. So we'll have here the mass times the response acceleration plus mu mg plus kx is equal to 0. As you can see, this is static, this is not dynamic. And then it doesn't, wala na siya nagkuan. Mag-change man sa velocity or dili, this is constant, the frictional force. So we call this our Coulomb's damping. Coulomb damping. Or static damping. So we know that friction, diba, because of friction, if we have vibration ani nga system, wala mo siya kahinay because the friction will always oppose motion. And then friction can also provide vibration damping. So by Coulomb's law, so ingon si Coulomb nga the friction force is proportional to the normal force developed between the mass and the surface. So the friction force, the constant of proportionality for that is the coefficient of friction mu. Or we have here the mu mg. Because here we only have the mass, therefore the normal force is just equal to the weight. And the weight is just equal to the mass times the gravitational acceleration. Okay? So take note of this formula. Again, ano po tayo bago nga formula i-consider diri. We have here, gitawag na to ni siya reduction in amplitude per cycle. Let's say, let's take note the reductions at amplitude as delta rho. So ang reduction ni amplitude, so si amplitude, di ba, musaka, munaog, musaka, muna siya sa usa ka system. Ang iyang reduction ana kada cycle is equal to 4 times mu mg over k. Pwede na sad para mas dali madumduman 4 times the frictional force over k. Take note of this formula. What else? And then the number of cycles. Para makuha na to si number of cycles n, the number of cycles n is just equal to total reduction over delta rho. So the total reduction will be 50% or 100% depending. But for this problem, 100% the total reduction. Kay ingon man niya the block returns to rest. So it will reduce until mo zero na siya ang amplitude. Another formula that you need to remember is the final rest position. So mo ni siyang kuan katong muhunong na si kuan si system or si this one the system. Let's represent that by u is equal to u naught or the initial position minus mu mg over k times cosine is the natural frequency times the time or the period that it stops plus mu mg over k. This is an additional formula. And napay last final yun. Say there is no reduction nga given or kuan, and then you don't have you don't know the idea when what is the final rest position. We know that frictional force, the static force due to the Hooke's law or the spring force is equal, if we equate that with the frictional force, so kung na-equate mo na to siya, it is because ang motion, muhunong siya kung ang spring force, dili na niya ma-overcome ang friction force. And then, dili na niya ma-overcome ang friction force when equal na sila. That's why we have here, Ku is equal to mu mg. Let's say KUF na lang ni siya. So our final position can also be solved with this one. Mu mg over k. Okay? Yeah, so let's try to solve this one. So we have here what we have here? You have mu is equal to 0.12. Mass is equal to 2 kilograms. K is equal to 10,000 Newton per meter. What else do we have? We have displacement. Initial displacement, U naught is equal to 10 millimeters or 0.01 meters. What else do we have here? Okay, let's start solving now. So first is something na to. We need to get the cycles. So the cycles to rest is equal to the total reduction over the reduction per cycle. So what is the total reduction? This is just the initial position minus the final position over the reduction per cycle. We have this one, U naught, that is 0.01 meters. But we don't have yet the final position. So sa ito siya pag-solve, we know that the final position is equal to mu mg over k. So we just substitute those values. You have 0.12 times the mass, 2 kilograms, times the gravitational acceleration, 9.81 meters per second squared, in the SI unit, over K, which is equal to 10,000 Newton per meter. Then we have our final position at 0.235 millimeters. Actually ang mugaw sa ning result is in meters, that is 0.00235 meters or 0.235 millimeters. Since naka millimeters man di ay na, just change this one here. So we have 10 millimeters minus 0.235 millimeters over. So again, the delta rho, that is the 4 mu mg over k. So we have 10 minus 0.235 over 4 times 0.12 times 2 nga mass is 9.81 meters per second squared over 10,000 Newton per meter. Total cycles, that is 10.39 cycles, or just say approximately 11 cycles. So pasabot ani at 11 cycles, the system already stopped vibrating. Paano siya ni-vibrate? There is no oscillations. Naman na siya. We have already solved this one.